Okay, in our application problem, it says the path that the rocket follows is modeled by f of x equals -1, x minus 3 quantity squared plus 9, where x is the horizontal distance in feet from the edge of the launch platform and y is the height in feet. Graph the path the rocket follows. So to start, we should already know that this exponent of 2 makes it a parabola. We should know that the negative flips it, so it's actually going to be a parabola kind of facing down like this. That was awful. Let me try that one more time. So it's going to be something like this. We don't need the calculator to start, so we can actually find the center or the vertex or the starting point by taking the opposite of the -3. That's your h, and then the exact k. So our starting point is 3 to the right and 9 up. So I believe that's about right here. Now for the rest of this, we can actually go into the graphing calculator and type that in. So I've already done that. And we're going to use the trace feature to type in points around 3. So I'm going to go to 4. It looks like 4 is at 8. So that's about right here. Then I'm going to go to 5. 5 is at 5. So 5, about right here. And I'm going to go to 6. 6 is at 0. I'm going to go to 7. 7 is at -7, which I believe is about right here. Now this graph actually has a line of symmetry. So I'm just going to do my best to draw that in. So the line of symmetry is here. Whoa. I don't know what that was about. Let me try that one more time. That was kind of awesome. So we're going to go right up to about here because that's as far as I need to go. Okay, so all I really have to do is reflect the points across that line. So if that's 1 away on the right, I'm going to go 1 away on the left and put a point. This is 2 away, so I'm going to go 2 away. I'm going to go 3 away, so I go 3 to this side. And then I go 4 this way, so I go 1, 2, 3, 4 this way. And then we do our best attempt at making a parabola. So this side heads down like so. And the other side heads down on this side like so. Okay. So this question now says describe the domain and range in context. Now this graph, if this graph didn't have a story, the domain would be -infinity to infinity because parabolas always do that. However, there are some numbers that don't really make sense. For example, if I think about what this represents right here on the x-axis, this is the distance away from the platform. We're not going to go negative. So our graph can't go negative because that doesn't make sense in our story. So for the domain actually starts at an x value of 0, including 0. Now, also, this graph, we're actually going to kind of cut it off right here at this point because as we go beneath here, that indicates the height, and the height is not going to go underground. So we're going to cut it off here at, I believe that is 6, I think. Let me just count it up. 1, 2, 3, 4, 5, 6. So our domain goes from 0 to 6. So what does that mean in context? The graph starts 0 feet away from the platform and it ends up 6 feet away from the platform. And you would have to write that down in the sentence. The range. When I look at the range, I'm going from the bottom to the top. Now again, this graph has a range that goes from -infinity all the way up to +9. But the problem is, in real life, this graph gets cut off here. And the reason why is because we don't really go underground. So our range is going to start at the ground at 0, and it's going to go up to 9. 0 is included, 9 is included, because we don't put white circles. We don't put white points, white dots. So what does this mean? It means the height of the rocket starts at 0, which means it's on the ground. And then the height that it reaches, the maximum height, is at 9. So the highest it goes is 9 feet, I believe.